It is generally not recommended to use both a ground fault circuit interrupter breaker and a ground fault circuit interrupter receptacle in series. This is because the two devices can interfere with each other, leading to nuisance tripping or failure to trip when a ground fault actually occurs. Ground fault circuit interrupters, whether in the form of a breaker or a receptacle, are designed to protect people from electrical shock by detecting ground faults. A ground fault occurs when current leaks from a hot wire to ground, such as through a person touching a live wire and a grounded object. The ground fault circuit interrupter detects this leakage by monitoring the current balance between the hot and neutral conductors. Under normal conditions, the current flowing through the hot wire should be equal to the current returning through the neutral wire. If there is a difference of more than a few milliamperes, the ground fault circuit interrupter will trip, cutting off the power to the circuit. When a ground fault circuit interrupter breaker and a ground fault circuit interrupter receptacle are used in series, they can create a situation where both devices are constantly monitoring the same circuit for ground faults. This can lead to one device tripping before the other, or both devices tripping simultaneously. This can be particularly problematic if the upstream ground fault circuit interrupter breaker trips before the downstream ground fault circuit interrupter receptacle, as this can leave the receptacle without power and unable to provide ground fault protection. In addition, the two devices may have slightly different tripping thresholds, which can also lead to nuisance tripping. For example, the ground fault circuit interrupter breaker may be more sensitive to ground faults than the ground fault circuit interrupter receptacle, and may trip even when there is no actual hazard. There are several reasons why it is better to use only one ground fault circuit interrupter device per circuit. Firstly, it simplifies the troubleshooting process. If there is a ground fault, it will be easier to determine which device is tripping and why. Secondly, it reduces the risk of nuisance tripping. With only one ground fault circuit interrupter device on the circuit, there is less chance of the device tripping due to minor fluctuations in current. Thirdly, it ensures that the circuit is properly protected. By using a single ground fault circuit interrupter device that is properly sized and installed, you can be confident that the circuit will be protected from ground faults. If you are concerned about ground fault protection in a particular area, such as a bathroom or kitchen, it is generally better to use a ground fault circuit interrupter receptacle rather than a ground fault circuit interrupter breaker. This is because ground fault circuit interrupter receptacles are typically less expensive and easier to install than ground fault circuit interrupter breakers. In addition, ground fault circuit interrupter receptacles provide local protection, which means that they will only trip if there is a ground fault in the immediate vicinity of the receptacle. If you do decide to use a ground fault circuit interrupter breaker, it is important to choose a breaker that is properly sized for the circuit. The breaker should be rated for the same amperage as the circuit conductors, and it should have a tripping threshold that is appropriate for the application. In general, it is best to consult with a qualified electrician before installing any ground fault circuit interrupter devices. An electrician can help you to choose the right devices for your needs and can ensure that they are properly installed and wired. It is important to note that ground fault circuit interrupters are not a substitute for proper wiring practices. Ground fault circuit interrupters are designed to protect people from electrical shock, but they will not prevent fires caused by faulty wiring. It is important to make sure that all wiring is installed in accordance with the National Electrical Code and local building codes. In addition to ground fault circuit interrupters, there are other types of overcurrent protection devices that can be used to protect electrical circuits. These include circuit breakers and fuses. Circuit breakers are automatic switches that trip when the current in a circuit exceeds a certain level. Fuses are devices that contain a thin wire that melts when the current exceeds a certain level. Circuit breakers and fuses are designed to protect electrical circuits from damage caused by overloads and short circuits. Overloads occur when too much current is flowing through a circuit. Short circuits occur when a hot wire comes into contact with a neutral wire or a ground wire. When an overload or short circuit occurs, the circuit breaker or fuse will trip, cutting off the power to the circuit. It is important to choose circuit breakers and fuses that are properly sized for the circuit. The circuit breaker or fuse should be rated for the same amperage as the circuit conductors. It is also important to choose circuit breakers and fuses that are appropriate for the application. For example, some circuit breakers are designed to trip quickly, while others are designed to trip slowly. Quick trip circuit breakers are typically used to protect sensitive electronic equipment. Slow trip circuit breakers are typically used to protect motors and other equipment that can withstand short periods of overload. The National Electrical Code, or NEC, provides comprehensive standards for electrical installations in the United States. It's crucial to adhere to the NEC to ensure electrical safety and compliance. The NEC addresses various aspects of electrical systems, including wiring methods, overcurrent protection, grounding, and equipment installation. Specific sections within the NEC, such as Article 210 for branch circuits and Article 230 for services, offer detailed guidelines for ground fault circuit interrupter protection. Furthermore, Article 406 covers the installation of receptacles, including ground fault circuit interrupter receptacles, in specific locations. Always consult the latest edition of the NEC and local electrical codes for accurate and up-to-date requirements. Ground fault circuit interrupter receptacles are often required in areas where electrical outlets may come into contact with water, such as bathrooms, kitchens, and outdoor locations. These ground fault circuit interrupter receptacles provide an additional layer of safety by quickly cutting off power to the outlet if a ground fault is detected. Ground fault circuit interrupter breakers are often used to protect entire circuits, including multiple outlets and appliances. These breakers are installed in the electrical panel and can provide ground fault protection for all devices connected to the circuit. When installing electrical wiring, it is important to use the correct wire size for the circuit. The wire size must be large enough to carry the maximum current that the circuit is expected to draw. If the wire size is too small, the wires can overheat and cause a fire. The National Electrical Code provides tables that specify the correct wire size for different ampacities. These tables take into account the type of wire, the insulation temperature rating, and the ambient temperature. For example, Table 310.15b16 in the NEC provides ampacity ratings for insulated conductors rated up to 600 volts. When working with electrical wiring, it is important to follow all safety precautions. Always turn off the power to the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, it is best to hire a qualified electrician. The electrical system in a building should be inspected regularly to ensure that it is safe and in good working order. Electrical inspections can identify potential hazards, such as faulty wiring, overloaded circuits, and damaged equipment. Electrical inspections are typically performed by qualified electricians or electrical inspectors. During an electrical inspection, the inspector will check the wiring, overcurrent protection devices, grounding system, and other components of the electrical system. The inspector will also look for any signs of damage or deterioration. If any problems are found, the inspector will recommend repairs or replacements. Regular electrical inspections can help to prevent electrical fires and other electrical hazards. It is also important to have the electrical system inspected before buying or selling a home. An electrical inspection can help to identify any hidden problems that could be costly to repair. In addition to electrical inspections, it is also important to perform regular maintenance on the electrical system. This includes checking the wiring for damage, tightening loose connections, and replacing worn or damaged components. Regular maintenance can help to extend the life of the electrical system and prevent problems from occurring. It is also important to keep the electrical panel clean and free of debris. Dust and dirt can accumulate in the electrical panel and cause the components to overheat. The electrical panel should be cleaned regularly with a vacuum cleaner or a soft brush. When working with electricity, it is important to be aware of the potential hazards. Electricity can cause serious injury or death. Always take precautions to protect yourself from electrical shock. Never work on electrical equipment when you are wet or standing in water. Avoid contact with bare wires or terminals. Use insulated tools and wear appropriate personal protective equipment. If you are not comfortable working with electricity, it is best to hire a qualified electrician. By following these safety precautions, you can help to prevent electrical accidents. Ground fault circuit interrupters are an important safety device that can help to protect people from electrical shock. Ground fault circuit interrupters are required in many areas where electrical outlets may come into contact with water. Ground fault circuit interrupters should be tested regularly to ensure that they are working properly. If a ground fault circuit interrupter trips frequently, it may indicate a problem with the circuit. If you have any questions about ground fault circuit interrupters, it is best to consult with a qualified electrician. The purpose of a ground fault circuit interrupter is to protect individuals from hazardous electrical shocks. It achieves this by continuously monitoring the balance of current flowing between the hot and neutral wires in an electrical circuit. In a properly functioning circuit, the current flowing through the hot wire should precisely match the current returning through the neutral wire. However, if a ground fault occurs, meaning that electricity deviates from its intended path and flows through an unintended conductor, such as a person touching a live wire, this balance is disrupted. The ground fault circuit interrupter is highly sensitive to these imbalances, typically tripping when it detects a difference of as little as 5 mA. This rapid response cuts off the power supply, significantly reducing the risk of severe electrical shock. This functionality distinguishes it from standard circuit breakers, which primarily protect against overloads and short circuits that could damage the electrical system but may not react quickly enough to prevent personal injury from ground faults. The installation of ground fault circuit interrupters is mandated in numerous locations to minimize the risk of electrical shock. These areas generally include locations where water and electricity may come into close proximity. Bathrooms are a prime example, requiring ground fault circuit interrupter protection for all receptacles due to the presence of sinks, showers, and tubs. Kitchens also necessitate ground fault circuit interrupter protection for receptacles serving countertops, as water and conductive materials are frequently used in these areas. Outdoor locations, such as patios, decks, and near swimming pools, are also subject to ground fault circuit interrupter requirements to safeguard against the increased risk of electrical shock in damp or wet environments. Furthermore, unfinished basements and garages often require ground fault circuit interrupter protection due to the potential for contact with grounded surfaces and appliances. The National Electrical Code provides detailed guidelines on the specific locations where ground fault circuit interrupters are necessary to ensure electrical safety. Regularly testing ground fault circuit interrupters is crucial to verify their proper functionality and ensure continuous protection against electrical shock. The testing process is simple and should be performed at least once a month. Each ground fault circuit interrupter receptacle features a test button and a reset button. To test the device, press the test button. This should cause the ground fault circuit interrupter to trip, cutting off power to the receptacle. If the ground fault circuit interrupter does not trip when the test button is pressed, it may be defective and should be replaced immediately. After the ground fault circuit interrupter trips, press the reset button to restore power to the receptacle. If the ground fault circuit interrupter trips frequently or immediately after being reset, it may indicate a ground fault in the circuit. In such cases, it is essential to investigate the cause of the tripping and address any underlying electrical issues. This may involve inspecting the wiring, appliances, and other devices connected to the circuit to identify and resolve any ground faults. If the source of the tripping cannot be readily identified, consulting a qualified electrician is recommended to diagnose and repair the problem. While ground fault circuit interrupters provide significant protection against electrical shock, it is important to understand their limitations and use them in conjunction with other safety measures. Ground fault circuit interrupters are designed to protect against ground faults, but they do not protect against overloads or short circuits. Standard circuit breakers or fuses are necessary to provide protection against these types of electrical faults. Furthermore, ground fault circuit interrupters do not eliminate the risk of electrical shock entirely. While they significantly reduce the severity of shocks, it is still possible to experience a shock if you come into contact with a live wire, even if a ground fault circuit interrupter is present. Therefore, it is crucial to always exercise caution when working with electricity and to follow all safety guidelines. In addition to ground fault circuit interrupters, other safety measures can help to prevent electrical accidents. These include using properly grounded appliances and equipment, avoiding the use of extension cords whenever possible, and keeping electrical cords and appliances away from water. It is also important to educate children about electrical safety and to teach them to avoid contact with electrical outlets and appliances. By implementing a comprehensive approach to electrical safety, you can significantly reduce the risk of electrical accidents and protect yourself and your family from harm. Furthermore, surge protectors are crucial for safeguarding electronic devices from voltage spikes. Surges can originate from various sources, including lightning strikes, power grid fluctuations, and the activation of high-powered appliances. These surges can inflict significant damage on sensitive electronic components, leading to equipment failure or reduced lifespan. Surge protectors function by diverting excess voltage away from connected devices, thereby preventing damage. It is crucial to select surge protectors with appropriate surge suppression ratings to effectively protect against potential surges in your area. Additionally, uninterruptible power supplies offer battery backup and surge protection, ensuring continuous power to critical devices during outages. Proper grounding is another vital aspect of electrical safety. Grounding provides a safe path for electrical current in the event of a fault, minimizing the risk of electrical shock. All electrical outlets and appliances should be properly grounded to ensure that any stray current is safely directed to the ground. Regular inspection of grounding systems is essential to verify their effectiveness. Damaged or corroded grounding wires can compromise the safety of the electrical system. It is also important to avoid overloading electrical circuits. Overloading occurs when too many devices are connected to a single circuit, causing the circuit to draw more current than it is designed to handle. This can lead to overheating of the wiring, increasing the risk of electrical fires. To prevent overloading, distribute electrical devices evenly across different circuits and avoid using multiple high-power appliances on the same circuit. Furthermore, it is important to be aware of the signs of an overloaded circuit, such as flickering lights, warm outlets, and frequently tripping circuit breakers. If you notice any of these signs, reduce the load in the circuit immediately. Extension cords should be used sparingly and only as a temporary solution. Extension cords are not designed to handle high power loads and can easily overheat if overloaded. If you need to use an extension cord, choose one that is appropriately sized for the intended use and avoid running it under rugs or furniture, where it can be easily damaged or become a fire hazard. Regular maintenance of electrical appliances is also essential for safety. Inspect appliances regularly for signs of damage, such as frayed cords, cracked housings, and loose connections. If you find any damage, discontinue use of the appliance and have it repaired by a qualified technician. Furthermore, clean appliances regularly to remove dust and debris, which can contribute to overheating. Finally, when working with electricity, it is always best to err on the side of caution. If you are unsure about any aspect of electrical safety, consult a qualified electrician. Attempting to perform electrical work without proper knowledge and experience can be dangerous and can lead to serious injury or property damage. A qualified electrician can assess your electrical system, identify potential hazards, and provide expert advice on how to ensure electrical safety.